Good morning, Year 11. So this is our lesson today on electromagnets, and we'll start like always with our kit quiz. So 1 to 5 on your mini whiteboards, please. And if you pause the video for 3 to 5 minutes and then just come back to the video when you've got your 5 key terms. Okay, so you've paused your video and you've resumed it, so now let's check our answers. So number 1 then, a magnet which produces its own magnetic field and it always has a north and a south pole is a permanent magnet. Number 2, a long coil of wire is a solenoid, and we'll look at those in some more detail today. Question 3, the force produced between a conductor carrying a current within a magnetic field and the magnet producing the field is the motor effect, and that's a future lesson. Question 4, positive test for hydrogen, so a squeaky pop upon ignition, so with a lit splint or a burning splint. And lastly then, question 5, the positive test for chlorine gas, and this would be bleached damp litmus paper, so it's turned white. Okay, so marks out of 5, and then let's get our books ready to start today's lesson. So today's lesson is on electromagnetism, and this is probably a concept that you may have done in Year 7 or Year 8 as well, and we'll just be adding a little bit of detail to that. And our learning objectives today are to describe how the magnetic effect of a current can be demonstrated, to draw the magnetic field pattern for a straight wire carrying a current and for a solenoid showing the direction of the field. Sounds more complicated than it is. It's simply recognizing something on a diagram and being able to draw it. Explain how a solenoid arrangement can increase the magnetic effect of the current. So this will all boil down to paper clips essentially. How can we change the arrangement of the wire to make the magnetic effect stronger so that you can pick up more material? So we will have done, I'm sure with you, the classic practical of how many paper clips can you pick up, or that is what we would be doing in the lab if we were in lessons. So let's start with the magnetic field around a wire. And so what you have to use for this is your right hand. So while you're listening to me on the video, look at your right hand and do the thumbs up gesture, just like the boy on the picture is doing. So he's got his right hand, his fingers are curled round, and his thumb is pointed upwards. Okay, now the line going upwards through the diagram, following the direction of the thumb, that is showing the direction of the current. And then if you notice that there are the circles drawn around the hand, those circles are following the direction of the magnetic field. So the magnetic field is creating this kind of circular effect around the current. If you turn your hand over, so you turn your hand over so that your thumb is pointed downwards, then your current will be going downwards, and now your magnetic field is going in the opposite direction. So this is what we call the right hand rule. So with the thumb of your right hand pointing in the direction of the current, so in the picture the current is heading upwards, your fingers then will curl in the direction of the magnetic field. And there could be exam questions in the future where you're given, say, the vertical line, and you would have to add on the circular lines with the arrows to show the direction. So if you then turn your hand down and keep those fingers curled round, you can see that now with your current going downwards, your magnetic field is going now clockwise. So it's going in an opposite direction to how it was before. So key information then to add to this, the strength of the magnetic field depends on the size of the current. So for example, 2 amps will have a weaker magnetic field compared to, say, 10 amps or 100 amps. And then the distance from the wire. So the closer you are to the wire that's carrying the current, the stronger the magnetic field. Okay, and so key information then, this is the right hand grip rule. You can only use your right hand for this. You cannot use your left hand. That will be used for something else. And the thumb shows the direction of the current, whereas the fingers, when they're all curled round, show the direction of the magnetic field. So it is worth producing a revision card now, so you pause the video and produce a revision card that shows labelled information. So for example, you'd label the vertical line as the direction of the current, and then the circular lines with arrows, that would be the direction of the magnetic field. And can you take a picture of your revision card, please, and upload it on Google Classrooms, because I'd like to see how you're getting on with this. So pause the video, make a revision card, take a picture and upload it onto Google Classrooms. And then if you haven't clicked yes on the register at this point, then you can pause the video and go and do that. Okay then. So let's look at solenoids then. So solenoids are very simply coils of wire. Okay, so you're taking a straight wire and you can wrap it around something and then you create that coil. That is a solenoid. So it's a bit like a spring in that it's coiled round, but it's a wire that is coiled, and you can see that in the diagram. Okay, so there you can see all those green coils that are connected to the batteries. So a solenoid can be made by wrapping a length of insulated wire into a coil and connecting it to a source of electricity. So the wire is insulated to prevent electric shock. So if we were doing this in the lab, we wouldn't just use exposed wire, because it wouldn't be safe, and also it also heats up quite a lot. But the insulation would keep you safe. The strength of the magnetic field can be significantly increased by inserting an iron nail. So if you take that coil and you insert a piece of iron, it doesn't have to be a nail, but a nail is just a good example, then what you've created now is an electromagnet. So the solenoid is just the coil of wire, but an electromagnet is when you attach that solenoid to a power source. So that could be the mains or it could be a battery. And then if you insert an iron nail or an iron core, it doesn't have to be a nail, it can just be a rod of iron, then you've now made something known as an electromagnet, and they can be switched on and off. So that's really good if you think about like car scrap yards. If you want to go and pick up a car to move it, you can switch the electromagnet on to lift up the car and then move it. But when you want to detach the car from the magnet, you then switch the electromagnet off, and then that would release the car. So the fact that you can switch them on and off is a really good point. So here's the picture with the iron nail. Remember, it doesn't have to be a nail. It could just be a rod of iron or an iron core. But it does increase the strength of the electromagnet. Okay, so it's time to draw a diagram now. So whether you do this in your book or at this point you're making another revision card, both would be useful. So draw this diagram on the right-hand side. Add in all the information that you can see on the diagram. But for number 2, the label that I want you to add is strong and uniform magnetic field. And that's basically where you've got all of those horizontal lines going through the middle. So you should be drawing this now. Now, based on a previous lesson, where would you label the North and South Pole? Where are the lines going from? Where are the lines going to? So we've done that in a previous lesson on magnetic fields. So where are the lines going from? Where are the lines going to? That would tell you how to identify the North and South Pole. So if you need longer to draw this, then pause the video. Or if you're going to make a revision card as well as doing it in your book, that's fantastic. So pause the video and give yourself time to do this. And I'll carry on. So again, I'm really sorry that you haven't been able to do many practicals this year, but there could still be questions about practicals, and so we do need to cover them still. So our aim of this investigation is to find out how changing the number of coils affects the strength of an electromagnet. So if, for example, we started with 5 coils, then 10 coils, then 15, 20, 25, you are increasing your independent variable. So you're changing the number of coils, and you would want to measure how effective that was. So how does increasing, say, from 5 coils to 25 coils in 5 coil increments, how would that change the ability of the electromagnet to, or how would it change the strength? And what we would need to do is, like I said, we would do a paperclip practical. So we would measure when you switch on your electromagnet with 5 coils, how many paper clips could it pick up? And then with 10 coils and 15 coils, 20 coils, 25 coils, how many paper clips can you pick up? So this is what it would sort of look like in the lab. So you'd have your iron nail, because remember that does increase the strength of the electromagnet, and it also gives you something nice to wrap the wire around to produce the solenoid. Remember, the solenoid is the coil of wire. And then you're connecting it up to a power source, and then obviously with an electromagnet we can turn them on and off. And what I want you to do now, this is the task, you need to design a results table. So the independent variable, that's the number of coils. So what are you changing in your investigation? That's the number of coils. And I've given the suggestion that we should go 5 coils, 10, 15, 20, 25. So that's your independent variable. The control variable then is what you keep the same. So what are you keeping the same? And then lastly, the dependent variable, what are you measuring? So we're measuring the number of paper clips that you can pick up. Now, going back to the control variable, what are we keeping the same? We're keeping the diameter of the coil the same. So look at how all of the coils have got the same diameter. So obviously in the lab you would measure that. We could just make up a number now. We can just say that they're all going to be 10 millimeters wide. So the unit would be millimeters. So create your results table, understanding that the independent variable is what we're changing. So that's the number of coils. The control variable is what we're keeping the same, so the diameter of the coil. And the dependent variable is what we measure. So we're measuring how many paper clips can you pick up with intervals of 5, 10, 15, 20, and 25 coils. So produce that results table. Okay, so here's some secondary data. So imagine we've been in the lab and we've collected some data. So we've got number of turns. So where they say turns, that's just another way of saying coils. So coils or turns, both are fine. And you can see then that they've gone up in 10 coil, 10 turn intervals or increments. So 0, 10, 20, 30, 40, 50, 60. That's a good range of data. They have done 3 tests and then they've calculated a mean. So this is a really good set of data. It's reliable. They've carried out repeats. And so that's a good thing then. Because it means then if you've got any outliers or any anomalous results, you can exclude those when calculating the means. So at quick glance, I don't think they've excluded any. There aren't any that seem to be quite far away from the normal. Okay, so what we can see there then is that for 0 turns, obviously then 0 paper clips. You don't have any wire, so you can't pick up any paper clips. For 10 turns then, you've got 4 paper clips picked up. But when you double the number of turns, so when you double the number of turns from 10 to 20, you double the number of paper clips picked up from 4 to 8. And so now we've got a trend. So that's a really good exam technique. If you're analysing a graph or data, if you can say what happens when you double this or something else doubles or triples, that's a good trend to use. So when then you double the number of turns from say 20 to 40 turns, the number of paper clips picks up, it almost doubles from 8 to 15, because obviously double 8 is 16, so it's almost. So we can see the trend is that you increase the number of paper clips that you can pick up when you increase the number of turns or coils of the wire on the solenoid, which means then we can say that when you've got more turns, you've increased the strength of the electromagnet. And what's the evidence for this? That, well, you're picking up more paper clips. Okay, so this is all about referring to the strength of the electromagnet. And here then, it probably would be time to make another revision card, because there are 4 ways in which you can increase the strength of the electromagnet, and you need to memorize these 4 ways. Okay, so number 1, you use a larger current. So instead of using, say, 1 battery, you could use 2 batteries, which would give you a larger current, and that would increase the strength of your electromagnet. So please can you be making notes from this little section, because these are such common exam questions about how you can increase the strength of an electromagnet. So number 1, use a larger current. Then put an e.g. increase from 1 battery to 2 batteries. Or we could increase from, say, 2 amps to 10 amps. Give yourself examples to help it make sense. Adding a soft iron core to a solenoid to make it an electromagnet. So you could technically do this practical about picking up paper clips without the iron core, but if you do add it, it will make your electromagnet stronger. Number 3 then, increase the number of turns of wire. So we've seen from the data that if you have more turns or more coils, you will be able to pick up more paper clips because you create a stronger magnetic field. And lastly then, putting the turns closer together. Sorry that the timer is obscuring the last bit. So putting the turns closer together. So just imagine now taking that coil of wire and squashing them closer together. That will increase the strength of the electromagnet. So look at how they've done that in this diagram. So these are such common exam questions about how to increase the strength of the electromagnet. And so it's really important that you memorize these 4 bits of information. So if you need more time to write this down or make a revision card, either you want to use the pictures or you want to give examples, pause the video and take the time to do that. Okay, so resuming the video then. So let's have a look at an exam question as well. So in this question, you will gain marks for using good English, organising information clearly and using scientific words correctly. Some students want to build an electromagnet. The students have the equipment shown below. So they have an insulated wire. Remember, that will prevent electric shock, and it will also stop heat from escaping from the wire so you won't burn yourself. You then have an iron nail. So think back to what we've said about how you can wrap the wire around the iron core, and then that will increase the strength of the electromagnet. And then you've got a power supply. So instead of using batteries for this one, you've got your power supply, but it does mean you can change your current. So for example, on the little picture, you've got 2, 4, 6, 8, 10. So you could go from, say, 2 amps to 4 amps, etc., etc. Then you've got the connecting leads. So how are you going to connect the insulated wire to the connecting leads and therefore to the power supply? So you could use that. And you've then got steel paper clips. So this is our dependent variable. How many paper clips can you pick up if, say, you had 5 coils or 10 coils? And then a wooden clamp stand. I think the intention of that is that you're not sort of doing it on the surface. You can lift the equipment up. So you could have your iron nail clamped with the coil of wire around it and then picking up the paper clips. So then we've got this sentence. Describe how the students could build an electromagnet, including your answer how the students should vary and test the strength of the electromagnet. So this is a method question. This is about writing, number 1, do this, use this bit of equipment. Number 2, then you would do this, use this, and explaining what order you would use the equipment in and how you would build the electromagnet. Now, it's up to you how you vary and test the strength of the electromagnet. You could just use the example we've given earlier about having more coils of wire. But what you could have is you could have, say, 20 coils or 20 turns of wire, and you could change on the power supply the current. So you would see how many paper clips can you pick up for 2 amps? How many paper clips would you pick up for 4 amps? And so you're not changing the number of coils, you're changing the current, because remember, we've said that increasing the current will increase the strength of the electromagnet. Okay, so I think really they're the 2 different types of method that you should be writing about, either increasing the number of coils or turns or about increasing the current in even increments, okay? So this is a 6-mark question, so it's now time to pause the video for 6 minutes. And remember, it's all about the sequence, so a method question should be set out in numbered steps. and you should be thinking, how am I going to build that electromagnet, and how am I going to vary and test the strength of the electromagnet? So pause the video for 6 minutes. Okay, let's review your answer. So here's just an example of what I've put. So wrap the insulated wire around the iron nail to form a solenoid, which is the coil of wire, and an electromagnet with the iron core. Number 2, use the connecting leads to connect the electromagnet to the power supply, specifically the wire to the connecting leads, not the iron nail. So you're connecting those connecting leads to the ends of the insulated wire, which is then wrapped around the iron nail. Suspend the electromagnet in the air using the wooden clamp and stand. Wood is an insulator. So I think it's just the fact that they've called it a wooden clamp and stand. Well, why is that? Well, if you use a metal one, it conducts electricity, so it makes no sense to use. Start with a low current. So this is now telling us what are we going to vary, what are we going to test, e.g. 2 amps, and count how many paper clips are attracted to the electromagnet. Repeat this process for 4 amps, 6 amps, 8 amps, and 10 amps. And I've put those numbers because I can see them on the picture of the power supply. Okay, so this method is good because it's set out in numbered steps. It's included all of the pieces of equipment. It's put them in the correct sequence. And we can see then that this method is all about starting with a low current and then increasing the current. But what's good about that bit is that I've actually set out the numbers that I would test. So 2 amps, 4 amps, 6 amps, 8 amps, 10 amps. If you did an alternative method for, say, the number of coils or turns, then 1, 2, 3 and would be the same. And then obviously for 4, you would say start with a low number of coils or turns, e.g. 5, and count how many paper clips are attracted to the electromagnet, and then repeat this process for, say, 10 coils, 15 coils, 20 coils, 25 coils. So it's ever so slightly different if you did that, and that's fine. So marks out of 6. And then what I would like to see is you take a picture of this exam question method that you've just written and upload that onto Google Classrooms, please. So I believe this is Friday. I'm actually recording this on a Thursday, so I shall see you next week for your lessons.